Okay, we're going to continue our discussion on weight and volume relationships after we have determined the weight and volume relationships, the relationships among certain volume relationships and weight relationships. Now let us apply those parameters, those formulas that we will be uh, encounter for weight and volume relationship. So let's have our sample number one. For a given saturated soil, we're going to show that the saturated unit weight is equal to 1 plus moisture content all over 1 plus moisture content times specific gravity. All of this are being multiplied to the specific gravity and the unit weight of the water. So basically, this is derivation. You're going to show, you're going to prove that you're going to prove that the saturated unit weight is equal to this equation. So we're going to utilize some formulas that we have encountered a while ago. Basically, we're going to start with the saturated unit weight, and of course, that is equivalent to weight all over volume. So for this one, for the weight all over volume, we have learned that that is equivalent to the weight of the water plus weight of the solid all over volume. And that is equivalent to the weight of the solid multiplied to the moisture content plus the weight of the solid over volume. So basically, this expression is equivalent to this equation. So however, we have learned that the weight of the solid is equal to specific gravity times the uh, volume of the solid multiplied to our unit weight of the water. So we also learned we have this expression that E plus 1 is equal to total volume of the voids plus volume of the solid all over volume of the solid, or this expression is simply equal to total volume all over volume of the solid. So from there, we can have this expression that the saturated unit weight is equal to 1 plus moisture content multiplied to G sub S, the specific gravity, times the unit weight of the water all over 1 plus E. So if we're going to substitute the value for our unit weight void ratio, this is the equation for the void ratio. If we're going to have the relationship between void ratio, moisture content, and specific gravity, you're going to substitute that one to this equation. And if you're going to simplify, manipulate this one, you're going to have this expression. So this is now our final answer. We just derived our given expression in the certain problem. So for number two, the saturated unit weight and the water content in the field are found to be 18.55 kilonewton per cubic meter and 33% respectively. Determine the specific gravity of the soil solid and the field void ratio. So for this one, we're given with our saturated unit weight and the moisture content. So since the saturated unit weight and water content are both ratios, it is convenient to assume that the total volume is equal to 1. So we also have this illustration a while ago wherein total volume is equivalent to 1. Using that concept, we're going to apply that in this problem. So we start with unit weight is equal, of course, to total weight all over total volume. So from there, we're given with the saturated unit weight, and we are given with, we assume that fully saturated, so meaning to say that the total volume is equal to 1. So if we're going to cross multiply, saturated unit weight is equal to the total weight all over total volume, we can get that weight, total weight is equal to 18.55 kilonewton. So from there, if we're going to have the total weight of our soil element, this is equivalent to weight of the solid plus weight of the water. Of course, weight of the air is negligible. So basically, from there, this can also express as weight of the solid plus moisture content multiplied to our weight of the solid. So this one is equal to the weight of the water. And you can have this expression, weight of the solid is equal to the quantity of 1 plus saturated unit weight. So using this expression, we can have this derivation wherein weight of the solid is equal to total weight all over 1 plus moisture content. Then you try to substitute the given values and you obtain that the weight of the solid is 13.95 kilonewton. From the weight of the water, which is, we're going to get the weight of the water. Of course, weight of the water can be total weight subtracted by weight of the solid, which is equivalent to 18.55 minus what we have solved here, 13.95, which is 4.6 kilonewton. Since we are given with our weight, unit weight of the water, of course, that is 9.81 kilonewton per cubic meter, we can have this expression that the volume of the water is equal to our weight of the water over the unit weight of the water. Actually, that is unit weight of the water is equal to the unit weight of the water over weight, or rather, the unit weight of the water is equal to the weight of the water over the weight of the volume of the water. And if we're going to get the value for the volume of the water, that is equal to 4.6 all over 9.81, and that is equivalent now to 0.469 cubic meters. Since we have stated that the soil element is fully saturated, so meaning to say our volume of the voids is equal now to the volume of the water, so which is equals to 0.469 cubic meter. So therefore, our volume of the solid now is equal to total volume subtracted by the volume of the voids, and that is now equal to 1 minus 0.469, and that is equal to 0.531 cubic meter. So therefore, from our expression that the ratio is equal to volume of the voids all over volume of the solid, you simply have to substitute the value, we obtain 0.883. And since our unknown data is the specific gravity of the solid, so we're going to have weight of the solid over volume of the solid times the unit weight of the water. You simply have to substitute the given values, so you get 2.67. This is now our final answer for the specific gravity of the solid. So that ends our discussion for weight and volume relationship. You have to take note that in weight and volume relationship, it is the start of the derivation of all the formulas that you will be using in soil mechanics. What is important here is you know the formula. It doesn't mean you have to memorize alone the formula. You have to understand the formula. Memorize the formula, understand the variable, how to use that one. With the given known data, basically you can solve a correct solution. You can have a correct solution for a certain problem. Soil mechanics is you will be bombarded with formulas. What is important here is you know how to use the formula to a certain problem, so that you can come up with a correct solution and of course exact answer. So this is different from your other courses. It's totally different. So what is important here is you know the composition of the formula, you know how to use that one. It's not merely memorization. Understand the formula and apply that to a certain problem. So that ends for module 1 for our soil and weight and volume relationships. So I just hope that you learned something as we start with our discussion in C401 soil mechanics. Thank you.